Good morning, everyone. So today I'm going to discuss Poisson distribution, and I've already given 2 lectures on binomial distribution. This is my first video on Poisson probability distribution. So Poisson probability distribution is also known as the limiting case of binomial distribution. I'll throw a little light on it. So what exactly are the cases in which the Poisson distribution can be defined? So here I have picked up on 2 examples on my left. This particular example can be dealt with binomial distribution. That means if I toss a coin 10 times, then and if head appears 7 times, so I am immediately being informed that head will not appear 3 times. So I have 2 data with me, that the number of times a particular event is occurring and number of times an event is not occurring. So easily I can apply a binomial distribution here. But if I take up an example of customers arriving in a bank, and let us suppose by doing some historical data, I came to know that there are 4 customers arrived to the bank per hour. So in that case, I am not able to calculate that how many customers do not arrive in the bank per hour. That means I can only understand the number of times a particular event is appearing, average number of times an event is particularly appearing, but I cannot calculate rather that how many times this event could have not appeared. So in those cases, the Poisson distribution is applied, Poisson probability distribution is applied. This is also known as a limiting case of binomial probability distribution. So these are the 2 examples to differentiate Poisson and normal distribution. I hope I made some sense here. If you still want some clarity, you can write in the comment box and I can get back to you on further more examples of differentiating binomial and Poisson distribution. Now I'll proceed with the Poisson distribution. I'll take up this particular example here. A research firm is investigating in the safety of dangerous road intersection. Historical data from the past police records indicates that an average of 6 accidents per month take place on this junction. So, and the number of accidents are distributed in accordance with Poisson distribution. And I just wish to calculate what is the probability of having 0, 1, 2, 3, 4, 5 or 6 accidents in any particular month, typical month, and what is the probability of 3 or fewer accidents, and the third is what is the probability of 2 or more accidents. So though it's a bad example to quote, but x I am taking small x, capital X is a random variable which is representing number of accidents or number of successes you can call. So I don't want to call accident a success, but that's how this example is written. So capital X is number of accidents that take place at this particular junction. So since it is given in the question that average number of 6 accidents per month takes place and it has calculated from past records, so for this particular data set, lambda, which is also known as parameter of Poisson distribution, is equal to 6. That means lambda is representing average number of times the event occurs in the particular given time period for which I am making the calculation. So lambda is 6 here given in the question. Now I'll throw a little light on the probability density function, which is given by Simon Dennis Poisson, and Simon Dennis Poisson has given this particular probability density function to calculate the Poisson probability distribution. He said probability of capital X is equal to X. That means capital X is random variable, small x is number of successes. It can be given by e raised to the power minus lambda, lambda raised to the power x divided by x factorial, where L lambda is average number of successes or occurrence, which in this case is 6. So I'll show a manual calculation right here for this particular problem. I'll show you the calculation for all 3 parts. So first of all, I'm interested in calculating probability of 0 successes. That means 0, 1, 2, 3, 4 or 5 accidents. So 0 successes I have calculated. Same way it can be calculated for 1, 2, 3, 4, 5. So P of x is equal to 0, small x is 0 in this case, and I have replaced all the values of the formula, e raised to the power minus 6 lambda raised to the power 0 by 0 factorial. That gives me 0.0024. That means 0.02% is the probability if I multiply it by 100. That will be 0.24% is the chance that 0 accidents take place in a typical month on this particular junction. Now the second question is what is the probability of 3 or fewer? That means 3 or less than 3. So probability of 3 or fewer successes or accidents actually in this particular case is given by x is less than or equal to 3, which will be x is equal to 0 plus probability that there is 1 accident plus probability there are 2 accidents and plus probability that there are 3 accidents. So this can be calculated, then I'll just compute the answer through Excel, but I've given you the conceptual framework how this probability can be calculated. Same way the probability of, okay, I just need to correct it, probability of 2 or more, so it is exactly 2 or more. Okay, rewrite it. 2 or more successes is given by a probability that x is greater than or equal to 2, is given by a probability of x is equal to 2 plus x is equal to 3 plus x is equal to 4 plus and so on. So number of accidents can be any number, so it can go up to infinitive, right? So I'll use this probability, which will become almost impossible to calculate. So I'll use this fundamental probability that sum of probabilities becomes equal to 1. That means what? That probability of x is equal to 0 plus x is equal to 1, 2, 3 and so on up to infinitive, that will become equal to 1. If there are infinite number of cases, that means I'm not able to identify that how many total possible values random variable can take, then of course I need to take it x is tending to infinity, small x is tending to infinity. So that I can take is equal to 1. But if it is finite, that means capital N I can put. That means if the number of values small x can take are finite, then it will be x is equal to n is equal to 1. So this, in a fancy mathematics, it can be written something like this. Oh, okay, I need to complete it up, sorry. So that is exactly probability that capital X is equal to x is given by equal to 1. That's correct now. So I'll be using this particular principle of probability to calculate probability that x is equal to greater than x is greater than equal to 2. So I have highlighted it in red. That means I'm interested in calculating this red portion. So it is pretty easy algebra to see that I can just take these two terms on the right hand side, and that can be given by 1 minus probability of x is equal to 0 and x is equal to 1. So I can calculate p of x greater than or equal to 2 by 1 minus probability of x is equal to 0 minus probability of x is equal to 1. I've just taken these two terms on the right hand side. So this is exactly means how you can solve it manually. Now I'll get back to my Excel program here. So I'm interested in calculating probability of 0 accidents, 1 accidents, 2, 3, 4, 5, 6, 4, alright, 5 and 6. So I'm interested in calculating this small x. So I'll use my Poisson distribution function straight away, Poisson.dist. It asks me for x, that means number of successes, which is one cell to my left. So it's not getting highlighted, I'll manually type it. It is in C5. So C5 is my number of successes. That means the cell in which x is equal to 0 falls. Then I'll select mean, that means average, which in this question is given by x is equal to lambda is equal to 6. I'll freeze it because I'll be using it throughout. And I have already discussed in binomial distribution function that I need an exact match. So I'll type an Excel code 0, or I can simply double click on false, anything I can do, because I want an exact match. That means x is equal to 0. And I hit return or enter. It gives me a value of 0.00248. That means probability of having 0 accidents in a typical month on this junction is given by this number here. I just drag it down and it fills up all the cells and gives me the probability of 0 accidents, 1 accident, 2, 3, 4, 5 or 6 accidents. So that's exactly how it's been calculated. I can cross check the formula by just highlighting it. Now I wish to see the cumulative probability results. So I'll be typing in again my Poisson distribution function. Poisson distribution interested in 0 successes. The mean is 6, which I'll be using throughout. So I freeze it, and rather than typing false, I type true. So if you want to understand how this cumulative probability function works, get back to my binomial distribution discussion of binomial probability distribution. There I've comprehensively explained how this cumulative and exact function works. And now I'm going to pull it down. And if you see that sum of these values is not necessarily equal to 1. Why? Because x I am taking, there can be any number of accidents. When I exactly, there could be 7 accidents, 8 accidents, 9, 10. So this cell here in which my cursor is placed, this sum is not coming up 1. And that's why it is not coming up, because X in this case could be anything. It could be any particular value. Like I have taken X tends to infinitive. Please look into my binomial probability distribution formula, video. There you will be able to find out why this total is not coming up 1. And you can post your questions in the comments anyways. So first of all, I want to interested in calculating A, what is the probability of having 0, 1, 2, 3, 4, 5 accidents in any month. So these are the probabilities which are answering question number part A. Now what is the probability of getting 3 or fewer successes? Now it is exactly probability of 0 plus 1 plus 2 plus 3. So cumulative function right here in this cell, let me highlight it. It calculates actually probability of 0 plus 1 plus 2 plus 3, and it gives me 0.15120. So I'm just going to replicate this cell right here. So that's my answer. Probability of less than 3 successes. So cumulatively 0 plus 1 plus 2 plus 3 is given here. Now probability of 2 or more successes. So I'm going to do it like 1 minus, if you look into the manual formula right here, let me just drag it up a little bit. That's fine. So I'm calculating now C part. So probability of more than 2 successes, it is given by 1 minus probability of, just initiate the bracket. So minus probability of 1 success, 0 successes, which is right here, plus the probability of 1 success, which is right here. So if you just drop a bracket here and here, you close these two terms in parentheses, this sign will go plus, and I hit return. So that gives me a probability that there could be, what is the possibility that there are more than 2 accidents in a typical month, where the historical data suggests there are on an average 6 accidents. So you can represent your answer in terms of percentage just by clicking here. So there is a 98% chance that 2 or more accidents can take place. Less than 3 accidents can take place as 15.12%. Again, you can convert all these values in percentage, raise 2 places to decimals. So that's what about the Poisson distribution. So that is one worked example of Poisson distribution. Please post your comments if you want to see more examples of such kind. Thank you very much.